All right, guys, here's a video that I think might help you out with some revenue problems here. So this is one that I wanted to work through with you just because I think it can be a little more challenging than the others. So I'm not going to read this to you. You can read the problem, but what's important to note is that when tickets to a movie cost $11, the average attendance is 248 people. When tickets were lowered to $5, the average attendance was 474 people. So there's an important concept right here that we need to talk about, and it's the fact that the prices determine the number of people in attendance, okay? Said another way, the number of people depend on the price. Now, those are some words that will take you back to algebra classes in the past, and we'll go over those concepts here in a few minutes. There's another important thing in our problem that we need to talk about, and it's right here. Assuming the demand function is linear, how much should a ticket cost in order to maximize revenue? So let's just go through a couple of things here. The revenue we're going to define to be R. N of P is the demand function. So the number of people depends on the price, and P is going to be the price of the tickets. That's what we're looking for, okay? Now, if you're not familiar with this notation, N of P, what we're doing is we're defining the independent variable, and over here, this would be the dependent variable. And we'll talk about what that means again in just a few minutes in terms of how do we actually work this problem. So let's go ahead and talk about a couple of things. First, we're creating our revenue function. Our revenue function is this thing. It's the demand function times the price, okay? So the first thing we need to identify is, what is N of P? What's that demand function? By now, you know that in calculus, we really need to take the derivative of something, but I don't have anything to take the derivative of. We're going to establish what that is by finding out what N of P is. The next thing we have to do is figure out how do I maximize revenue? And then lastly, we'll identify what the answer is. Now, you see I've got this equation, y minus y1 equals mx minus x1. And you may be wondering, well, how did we even know to write that down? In the problem, it says, assuming the demand function is linear. Okay, so this is the basic equation of a line, just one of the versions, y minus y1 equals mx minus x1. In order to write that equation, we're going to need to know what the slope is. Okay, well, you know that we can find the slope by using the slope function. So the slope equation. It's the y values on top and the x values on bottom. So you may be looking at the way we have the coordinates written, and you may wonder, well, y is 11. How did I know to make 11 the x value? That's a price. How did I know that was going to be an x value and not a y value? The reason prices are the x values is because the prices determine the number of people. So the number of people would be the dependent variable. The price would be the independent variable. Okay, so what we're going to do then is we want to make sure that we have these x values on the bottom and the y values on the top. And this will help us identify what that slope is. So that comes out to negative 226 over 6. And we're going to simplify that slope down to this, negative 113 over 3. Okay, now that we know that our slope is negative 113 over 3, we can go in and plug some information into that equation. So we're going to have y minus 248 equals the slope times x minus that price value of $11. Okay, well, we've got y minus 248 equals negative 113x over 3. So we're distributing that 113. Let's figure out what 113 times 11 is. I've got my calculator here. I'm multiplying those values together, and it's a positive 1243 over 3. Well, now I'm going to add 248 to both sides. But I'm not just going to add 248. I'm going to go ahead and get a common denominator, which would be 3. And it would change the 248 to 744. Again, we're rewriting 248 as a fraction so that we can add those together. 1243 plus 744 is 1987. So we have our equation for that demand. Okay, so this is 1987 over 3. This is Y, or we could call that N of P, but we'd have to change the X to a P. So again, just some notation type things here that are probably, maybe a little foreign to you. But basically what we're doing is we're letting N be the Y value and P is the X value. Again, that comes from that N of P here. Okay, all we did was figure out what the demand function is. Remember, we want to maximize revenue, so we've got to take the derivative of this thing. Well, we're going to go rewrite that equation. It's going to be the revenue function is going to equal the demand function, negative 113, excuse me, I'll get this ready here in just a second, negative 113 over 3p plus 1987 over 3. Okay, this is our demand function, and we're going to multiply that demand function by p. All right, well, let's just distribute that p. It'll give us negative 113p squared. That negative 113 should be over p, plus 1987 over 3 times p. Because we want to maximize, again, we want to maximize revenue. That's the word that tells me not only do I need to take the derivative of the revenue function, okay, so I'm going to take the derivative, but I'm going to set that derivative equal to 0. And again, that comes from the idea that we want to maximize this revenue. Okay, so I'm finding out when is this derivative equal to 0, and that is going to tell me when there is a maximum. That takes you back to the stuff that we did right before the midterm, I believe. So we've got this, and on the other side we have negative 1987 over 3. To get p by itself, we're going to take negative 1987 over 3, and we're going to divide by that or multiply by the reciprocal. You'll notice those 3's cancel. So our final answer is going to be negative 1987 over negative 226. I'm going to need my calculator for that one. 1987 divided by 226 comes out to 8.79, or $8.79. That's the price of a ticket that will maximize our revenue. Okay, so again, we wanted to know how much money do we need to charge so that we get the maximum amount of people and the maximum amount of money out of our mall. Good luck with that one. Let me know if you have any questions.